Hey everyone, this is the Algebra 1C Semester 2 exam review. I think this video will cover the first half of the review, so like the first 3 pages, but we'll kind of see where we end up time-wise. So whatever the written title on this video is, that's what we're going to cover. So let's start with number 1. Evaluate 4 to the power of negative 3 and show your steps. Now I showed you that you could take 4 to the negative 3 and type it in your calculator. You do want to make sure after you do that you convert it back to a fraction, because we would want your final answer as a fraction. But because I was specific about showing your steps, here's what I'm looking for. Okay? A negative exponent does not make your answer negative. That's a big mistake that people make. A negative exponent just means that this is going to end up being a reciprocal. So up on top I'm going to have a 1, and on the bottom I'll have 4 to the third. It's positive now because I've moved it to the bottom, okay? Which really is like doing 1 over 4 times 4 times 4. And that 4 times 4 times 4, that's equal to 64. So your final answer here would be 1 over 64. Okay? All right, number 2. A lot of mistakes I saw on this one. A to the power of 0, this piece right here is equal to 1, and lots of you know that. Lots of you know that anything to the power of 0 is equal to 1. But by order of operations, I need to do that power first. So really what this is saying, make it a little bigger here for us, really what this is saying is to take A, raise it to the power of 0, and then multiply by 3, because exponents come first. So, let me get this back to where we started. Looks about right. A to the power of 0 is equal to 1, and really what this is saying then is 3 times 1 is equal to 3. So final answer is just 3. It's not 1, okay, because just the one piece of it is 1. A to the power of 0 is equal to 1, but your final answer would have to be 3. Okay. Oh, and honestly, I didn't even notice that this said A equals 4. That really doesn't change our answer. Let me redo it with the A equaling 4. Sorry about that. If I did 4 to the power of 0, if I wrote it out this way, 3 times 4 to the power of 0, which is what this would look like, I would still do 4 to the power of 0 first, which equals 1. So this would be 3 times 1, which is 3. So honestly, the fact that there was a number there doesn't even change your answer, because anything to the power of 0 equals 1. Okay, next one. Simplify 2/3 to the power of, and I know that's a little bit hard to see, sorry about the formatting there. That's 2/3 to the power of negative 4. Well, 2/3 to the power of negative 4, remember that a negative exponent turns things into the reciprocal. So this negative right here is going to make this fraction flip over. So it's going to end up looking like this. The 3 will be on top, the 2 will be on the bottom, and then we'll be raising to the power of positive 4. It's not negative anymore because it already did its job. The negative's job was just to flip the fraction over, and since we flipped the fraction now we're good. Okay? And now I'm just going to take 3 to the power of 4 and 2 to the power of 4. 3 to the 4th in your calculator, you should come out with 81. And 2 to the 4th in your calculator should come out with 16. And that would be your final answer, 81 over 16. You could type this all into your calculator at once. I would be careful that you put the parentheses in just how they're written in the problems. Just make sure that you tell your calculator to convert your final answer back to a fraction, because that's what your answer is going to be given in for the exam. Okay? Okay, let's move on to number 4. And again, the formatting got a little messed up here. This says 2x to the 4th times 3x to the 5th. When you're doing a problem like this, what I want you to remember is that you multiply the coefficients, and the coefficients are like the numbers in front of the variables. But when you're multiplying powers, you add exponents. So the little tiny numbers up above the x's, you're going to add those together. Okay? So as far as your final answer, I would take 2 times 3 and get 6. And then x to the 4th times x to the 5th, I'm really going to end up doing 4 plus 5 is 9. So my final answer would be 6x to the power of 9. Okay, on to number 5. 2m cubed and then that whole thing squared. What you have to make sure you do here, and let me make this bigger again. What you have to make sure you do is you have to square the 2 and you have to square the m cubed. Now squaring the 2, that's going to be easy. Let me make this smaller again. 2 squared is just 4, because 2 squared really means 2 times 2. So 2 squared is 4. Now your rule for raising a power to a power, if you think about this literally, if you have a hard time memorizing the rule, think about what this really means. M to the 3rd looks like this. M times M times M. And then the square means you have that twice. M times M times M. So total I have 6 m's. Really what I did was I multiplied those exponents together, and that would make my final answer 4m to the power of 6. Okay. If you need another way to look at that same problem, let me write it a different way. 2m cubed squared is like 2m cubed times 2m cubed, because that's what it means to square. Oops, that's supposed to be a cube. Yeah. To square something is to multiply by itself. So 2m cubed times 2m cubed, remember we would multiply the 2 and the 2 and get 4. And we would add the 3 and the 3 and get 6. Okay, just like in the previous problem, we multiply the coefficients, we add the exponents. So either way, you end up with 4m to the 6th. Okay, onward. Number 6. Classify according to the degree and its number of terms. Degree means its highest exponent. Its highest exponent is 2, and we did a lot of work with these type of functions, but if the highest exponent is 2, it is a quadratic. Remember, anything with an x squared, where the x squared is the highest exponent, is a quadratic function. And the number of terms, there are 1, 2, 3 terms here, so this is a trinomial. So I would call this a quadratic trinomial. Okay? Okay, let's keep going. Number 7, subtract. Oh, the subtraction ones of these are always tricky. Make this bigger too. Okay, notice this is subtraction in the middle. Don't forget that. I'm going to combine like terms here. However, the fact that this is negative means that I need to be subtracting these two things. The two things over here in the second set of parentheses need to be subtracted from these. So, 2 different ways you could do it. Let's do it the way probably that would be the simplest for you. 4g cubed minus 7g cubed. 4 minus 7 is negative 3g cubed. Remember, when you're doing that, the exponents don't change. And then 5h minus negative 6h. Don't forget that that's really a negative 6. That negative goes with the 6. So 5h minus negative 6h. Let me write that out separately so you can see it. 5h minus negative 6h. Think about what this means. Okay, when you subtract a negative, it's really like addition. Okay, so this is really going to become a positive 11h. Okay, so that's one way to do this. The other way you could do this, if you wanted to, is remember that this negative sign can be distributed to both of these things in here. So I could rewrite this whole thing as 4g cubed plus 5h, and then if I distribute that negative, that's going to become a negative 7g cubed. And when I distribute that negative to a negative 6h, it'll become a positive 6h. And then from there, most of the time you guys seem most comfortable with changing this to plus a negative. Anytime you have a minus, it's plus a negative. And then we would just combine like terms. 4 and negative 7 give you that 3. and 5 and 6 give you that 11. So whether you want to write it out like this or whether you just want to make sure that you're doing subtraction and not addition, you can go either way. Okay. The biggest mistake I see with these is a lot of people remember to subtract this first one, but then they end up adding the second term because they forget that this negative sign goes to both of these things. So just be careful with that. Okay, on to number 8. Number 8, when you're multiplying two binomials, we can use the acronym FOIL. First, outside, inside, last. Okay, so first I would do x times 4x. Well, remember in front of this x there's really like a 1. So I would do 1 times 4 is 4. I think you guys actually wrote it out like this, it looked like, when I went through your papers. So x times 4x, that's 1 times 4 is 4, and x times x is x squared, so this would be 4x squared. Outside would be x times negative 2, don't forget that that's a negative 2. X times negative 2 makes negative 2x. Inside, 3 times 4x is 12x. And last, 3 times negative 2 is negative 6. When I go to combine these things, and the other thing I saw, some of you when you were doing this on your other review packet, you left it like this. You have to make sure that you write it out as one final answer and that you combine the things that can be combined. Now you can't combine the x squared with those because that has a square on it, but your final answer would be 4x squared. If I do negative 2x plus 12x, negative 2x plus 12x, that gives me 10x, and then minus 6. And that would be your final answer. Okay, number 9 is very similar, but again, you've got to work with this square thing. Okay, when you see this square there, that means you're going to have to write these parentheses out twice. So it really means that you're working with 3x minus 2 times 3x minus 2. And I really recommend that you write it out like that. Okay, I see a lot of mistakes when people don't write it out like that. This is now a similar problem to number 8, FOIL. So first would be 3x times 3x, which is 9x squared. Outside, 3x times negative 2 makes negative 6x. Inside, negative 2 times 3x is also negative 6x. And last, negative 2 times negative 2 is positive 4. Now I'm going to go about combining things. Again, I can combine the O and the I. Do not be fooled into thinking that these two things cancel each other out. Negative 6 and negative 6 make negative 12. So for my final answer here, let me put this in a different color so you can see it. Final answer would be 9x squared minus 12x plus 4. Okay, let's move on to the next page. Okay, prime factorization of 360x squared. Well, to do a prime factorization of 360, we'll need a factor tree, and I'm going to try to put this off to the side here. So 360, remember it doesn't really matter how you start your factor tree. You should come down to the same factors at the bottom. I know that 360 is equal to 36 times 10, that 36 is equal to 6 times 6, that each of these 6's is a 2 and a 3, and that this 10 is a 2 and a 5. Okay, so for my 360, I would say 2 times 2 times 2, and yes, it would be okay if you wrote 2 cubed, but just make sure you can recognize the answer either way because it will be multiple choice. I've got a 3 and a 3, and then a 5. Right there. Now remember, I don't want to use these other ones like the 6 or the 10 because those have been broken down already. You only want to use the numbers that are at the very bottom of your branches. Now let's look at the x squared. Well, x squared is equal to what times what? Hopefully you're thinking x times x. So just to deal with this x squared on the end here, I should list times x because x squared is x times x. If that was x cubed, I would write 3 x's there. Okay, GCF of 64 and 80. The technical way we should do these, again, is with a factor tree. So for 64, you know what, let me do this in a different color so it doesn't blend in with the last problem. $64 I know is 8 and 8. Each of those 8s is a 2 and a 4. And each of those 4s is a 2 and a 2. Okay? So for my 64, I end up with 2 times 2, I think there's 5. 6, sorry. Okay, that's my prime factorization for the 64. When I go to do 80 I know is 8 and 10. 8 is 2 and 4. 4 is 2 and 2. And 10 is 2 and 5. So it looks like I have 4 2s and a 5. Okay, and then for our GCF, we want to look at what they have in common. Okay, and in common, it looks like I have a 2 and a 2 and a 2 and a 2. So for my final answer, and I'm going to get rid of this factor tree now. If you need to see it, just hit rewind, but let me get rid of this so that I have some space. For my final GCF, I would do, well, I'm going to need more room than that even. We do 2 times 2 times 2 times 2, which is equal to 16. So my GCF of 64 and 80 is 16. The biggest thing that goes into both of them would be 16. Okay, let's go ahead and do prime factorizations for 24 and 40. I'm going to use sort of the same approach. If I start with the 24 factor tree, 6 and 4, 2 and 3, 2 and 2, 40, just get both my factor trees out of the way here, 4 and 10, 2 and 2, 2 and 5. So for 24c to the 4th, my prime factorization would be 2 times 2 times 2 times 3. That's just from the factor tree. 2 times 2 times 2 times 3. And then 4 C's. Okay. For 40, C to the 6th, looks like I have 2, 2, 2, and 5. And then it would be 6 C's after that. Oh, not letting me erase my GCF. Hold on. Well, it won't let me get rid of that factor tree, so unfortunately I'm just going to have to write over top of it. This would be 6 C's. Okay, and then I want to look for what these two prime factorizations have in common. Looks like there's a 2 and a 2 and a 2, and then 1, 2, 3, 4 C's that they have in common. So I've got 3 2's and 4 C's. So for my final GCF, and I'm going to have to run all the way over here, Remember, 4 2's, was that right? 3 2's, 4 C's. So for my final GCF, it would be 2 times 2 times 2 times C times C times C times C, which would actually equal 2 times 2 times 2 is 8, and then I would write this as C to the 4th. So my GCF of those two terms would be 8C to the 4th. I know that seems like a lot of work. Some of you may be able to look at 24 and 40 and know right off the top of your heads that 8 is the biggest thing, and I would love for you to get to that point, but a factor tree is the safest way to go. Okay, so 13, factor by pulling out a GCF. So really here we should do the same thing. We should do a factor tree for 15, for 25, and for 30. But I'm hoping that you can look at those and see that the biggest thing that would go into all three, 15, 25, and 30, would be 5. And then the largest amount of x's I can pull out, if you look back up here at number 12, here I had 4 C's, here I had 6, but the most I could have in common is 4 because the top one only had 4. So it's always the smallest number in terms of the exponent that you're going to be able to take out for a greatest common factor. So I have 4 x's, I have 8 x's, and I have 2 x's. The most I could possibly have in common is 2 because this one down here only has 2. So I'm going to end up pulling out 5x squared. Now the thing is, this is a little bit different than what we were doing previously. Previously, this is all we wanted, was to find this GCF. But now we're going to factor with it, which means I need to say what would be left over if I took out that GCF. And when I say take out, what I really mean is I want to divide. Okay, I want to divide all of those terms by that 5x squared. So 15 divided by 5 is 3. And if I take 2 x's out of 4 x's, I would be left with 2. Okay? That is subtraction. I know you're thinking, oh my gosh, Mrs. Strigno, you just told me I was supposed to divide. You are dividing. Remember the rule when you're dividing with exponents is that you would subtract the exponent. So x to the 4th divided by x squared would be x squared. Okay? And then minus 25 divided by 5 is 5. And x to the 8th divided by x squared would really be like 8 minus 2, which is x to the 6th. Plus 30 divided by 5 is 6. And this one only had x squared, and I took out an x squared, so this one has no x's left. So my final answer would be this right here, 5x squared times 3x squared minus 5x to the 6th plus 6. And if you really wanted to make sure you were right, you could take this and redistribute it. Okay, you could do the distributive property here, and when you do that, you should come back out to this final answer, or to this original problem, I mean. Okay. 14, factor by unfoiling. Remember, unfoiling looks like this. We've got 2 parentheses, and an x and an x. So let's talk about how we learned our signs. Our signs here, if this is a negative 27, think about how you could possibly multiply to get a negative number. Hopefully you're thinking that you would end up with 1 plus and 1 minus. All right, we need numbers now that multiply to make that 27, and that add to make that 6 in the middle, or that negative 6. Okay. So we need to think of something that multiplies to negative 27, and we know one's going to be positive, one's going to be negative, and that adds to negative 6. And just keep in mind when you're adding a positive and a negative together, that's really going to end up being like subtraction. So when you're trying to come up with your pair of numbers, instead of thinking adding to negative 6, let's think subtracting to 6. Okay? If you need to, you could make a list of all of the different ways you could multiply to 27. Okay, you could do 1 and 27. 2 doesn't go into it evenly. If you weren't sure, type in 27 divided by 2 on your calculator. You'll get a decimal. 3 and 9 work. Do 3 and 9 subtract to make 6? Yes, they sure do. And the rule we talked about in class was if this middle number is negative, if we want our sum to come out to be negative, then we want our bigger number to be negative. Okay, because that's going to carry more weight. It's got a larger absolute value. So -9, +3. And again, I could FOIL that back together to make sure, but really all I would need to check is, does 3 times -9 equal -27? Yes, it sure does. And does 3 plus -9 make -6? Yes, it absolutely does. Okay, 15. Factor is a difference of two squares if possible. Remember we talked about those special numbers that were perfect squares and we made a big list. I would love it if you had those memorized. But if you don't have them memorized, that's okay. If you're checking to see if something is a perfect square, take a square root of it. All right, we know x squared is a perfect square because it's written as something squared. But type in square root of 30 on your calculator and you're going to get a big crazy decimal. That's because 30 is not a perfect square. So that's where this if possible thing comes in. This is not possible. And for your reasoning, it would just be that 30 is not a perfect square. 30 is not oh, handwriting is getting messier. Sorry. Okay, 30 is not a perfect square. But let's try that same thing on number 16. Square root of x squared, square root of 100. We know this one's going to work, the square root of x squared, because x squared is a perfect square. And square root of 100 comes out as 10. So if you do the square root of x squared, you get x. If you do the square root of 100, you get 10. And remember the trick for factoring these is to take these two factors and have one plus and one minus. Okay, so that's your difference of two squares there. All right, 17, last one on this page. We'll probably cut off this video after this problem. Determine whether or not the function below is quadratic and justify your answer. Remember, from looking at a table, a function is quadratic if its second differences match. So I want to do 6 minus 18. When I do 6 minus 18, I get -12. Then I would do 2 minus 6, and I get -4. 6 minus 2, I get +4. 18 minus 6, and I get +12. And 38 minus 18, and I get +20. Then I would go for my second round. I would do -4 minus -12. Careful about how you type that in. -4 minus -12 should be +8. 4 minus -4 is +8. 12 minus 4 is +8. And 20 minus 12 is +8. So this would be my first differences. This is my second differences, and my second differences do all match. So I would say yes, this is a quadratic because second differences match. Okay, simple as that. All right, I'll pick up with the next page in a separate video.